Good evening to all. So this will be the third video in the series. So as we have keep on watching, I hope that you are getting some benefits or getting some clarifications uh, is coming into the subject. So the today's subject, what we are going to talk for next couple of minutes uh, would be the integrated steel plant. What strategies are being talked uh, for uh, for reducing the carbon footprint into blast furnace BOF rooted plants, particularly in forest, particularly in Europes. So one of the action which has been taken by Japanese as such, as well as Koreans, are to install an electric arc furnace. Number one, install an electric arc furnace, and of the equivalent capacity of blast furnace hot metal comes out tons per hour, and converted tons per hour, and then so the process route is divided. So one is conventional process route, blast furnace producing hot metal comes to converter and to produce the steel. That is the original process. So blast furnace will produce the same quantity, but but they are putting an electric arc furnace in between. So in the sense that scrap comes to electric arc furnace that already produces a liquid steel, and then that will be added with the mixing of LD converter steel and the scrap based steel, and then come out with the total overall mix. So previously, suppose blast furnace hot metal is coming as 1.1 ratio of liquid steel. The same ratio is now divided into 50-50. 50% coming from liquid steel electric arc furnace, and 50% coming from blast furnace. So in that manner, the overall CO2 load is become half, and that is the first step they have taken, in a very smart step they had taken without wasting the time. Second thing what they are doing is that they are procuring HBI into a different shape, into a smaller shape, which can be charged into the blast furnace, so that the whole blast furnace productivity goes up by tremendously high. As you know that blast furnace goes by 1 2 3 formula of production, coke rate, and energy. So that productivity goes up, coke rate comes down, oxygen increases. And third thing, what I have mentioned into the earlier videos, that more pellet feed operations, so that you can have less coke rate, more Fe agglomerated burdens, and then reduce the total carbon rate, and oxygen levels increases. So these three factors is particularly the installing an electric arc furnace inside the blast furnace complex is is phenomenal, and people are planning for 20 electric arc furnace into one complex, so that for next 5 years, 6 years, 10 years, in different phases of the project, so that they can reduce the CO2 load substantially. This is one of the important aspect today, where you don't need to scrap everything, no need to redo everything, and you can use it. Second part is hydrogen. I think you all know hydrogen is a big story today in the media. Everywhere we talked about hydrogen. We talk about hydrogen trains, we talk about hydrogen cars, we talk about hydrogen as an energy source for future generation, for decarbonization, entire drive of minus 1.5 degrees centigrade temperature for the earth. So that whole thing, hydrogen plays a critical role. Now hydrogen is possible and is feasible and economically feasible also. I'm not saying economically not feasible, provided 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 these power operators and hydrogen operators shake hand together well. Today, India as a country, or GCC as a country, you can get the green power at cheaper source. Now, what is the problems of green power? green power is the availability, in the night availabilities. So the electrolyzers are backed up in such a manner that it can produce 24 hours hydrogen basis. So if you have a hydrogen with a comfortable price, I'm not saying the price will be same as natural gas, then you can apply that hydrogen to produce DRI easily, and that DRIs are low CO2 DRIs and can be used in electric arc furnace. The people, there are the people who are attempting this through the hydrogen applications into DRI. I think you have seen the one of the Nobel project which is coming up in Sweden, particularly Europe. But we are in a much better position because our sun rays are better, we are more warmer, and so on and so forth. So hydrogen potentials in India is much more than Europe. Unfortunately, this or fortunately, this is the area where need to be drive today very heavily and very with the intense focus, so that hydrogen come out with a affordable price. India does not have any natural gas, so anyhow, hydrogen price will be higher than natural gas, but it will be not so high that it cannot be affordable for steel making. Once hydrogen comes in, where it can be used? It can be used in DRI, it can be used in blast furnace too. Although blast furnace use of hydrogen in blast furnace is a bit premature, but this hydrogen DRI and to use in electric arc furnace to further the CO2 load and to add into with the BOF circuit and to produce the steel is a future route and most promising economical route. So that, but here is a way you can reduce the CO2 load. That can be one of the path for India. So the another path for India can be if we get a comfortable price of hydrogen. Say today, if you are getting hydrogen of Indian rupees $1.5 to $2 per kilo, which is feasible, then you can have DRIs which is also affordable, and the price close to not same as scrap but higher than scrap, but it will have a much more positive impact. So the hot metal cost of today with blast furnace is comparable with this theory of DRI from hydrogen. And then where it can be used further, can it be used in everywhere in the combustion process? I'm not saying no, but I am saying only challenging and time to case basis. Suppose India got another advantage that pelletizing processes are India mostly travel grade, except one or two plants in grade clean in nature, where in travel grade you can have the hydrogen burners today ready, which can be applied. And the travel grade CO2 load is lower than grade clean, is almost half of grade clean. So that pellet goes to Indian circuits of steel making, which is advantage. Second area where it can be used is electric arc furnace, but it is minimal use because you can use hydrogen to shroud the steel. So shrouding, so consumption maybe 1 to 2 normal meter cube per ton of liquid steel. It's not that high consumption. Then if India goes for electrical steel area or other areas, there hydrogen is required to produce electrical steel, particularly EV grades and so on. There it will be used. So this is what about hydrogen. And hydrogen steel making is a easy subject, is not complicated. But having said that, Indian iron ore to stand with hydrogen, I personally have a doubt. Some research has to be done, particularly detailed high temperature test work has to be done on iron ore to stand on hydrogen, because hydrogen accepts a single phase. It doesn't accept double phase in iron ore. That is a hard fact, and we have to agree to that. So your ore preparations, your beneficiations, all has to be conducive to that part. People do use, I think you might have seen that our great technology providers talk about the mini induction based furnaces below reactors, DRI reactors, to make the molten metal and then to use back into in the converter. That is another process that is also as a feasible a process, and some plants are coming up in Europe and some plants are being talked in China. And I think, if I am not mistaken, China has again commissioned another hydrogen based DRI plant of a 1 million ton about last week or so. Previous to that, there is a one plant also lower capacity, 500,000 ton capacity. So technologies are being matured, applications are be there. So hydrogen is an important part and parcel of us. And the time we retire, or already we are about to retire, so we may not see those greens, but our next generation we will see it. And today is a time to focus on that: green steel, steel, hydrogen steel making. Now, next thing which will come in, not today but next 10 years later it will come, our all steel specifications are going to change. I tell you today in 2024, but if you see that next 10 years or so, this all our steel specification will be changed. Why it will be changed? Because we will be drive towards lower carbon economy. So suppose DRI produces 0.5% carbon and you will finish at 0.3% carbon levels. So there no point you are again oxidizing the steel and do it. So you have to think intelligently how we can make 0% carbon DRI, which is 100% hydrogen, which is DRI is possible, technology is possible, but steel melting side also have to work on that. How to make it 0% carbon steel, how to melt it. So whether electric arc furnace, or is a different furnace, electrical systems without oxygen, different land sinks, etc. This is going to drive the technology, and for which specifications also will change. Today the mild steel specification, anything you say, ASTM A36, SS400, you talked about 15-20 carbon, 0.15 to 0.20 carbon, that will be lowered down. In order to make this technology marriage with the specification, so that we are in a better era. Lastly, on this subject, very 1 or 2 minutes more to go, is that we can use some waste in steel making. What are those wastes? Plastics. Plastics is one of the beautiful thing which we can use it in place of coal to reduce the CO2 load. But this is another subject, another research, and we will discuss this at length in next any of the presentations. And perhaps I think we talked about hydrogen, we talked about DRI, we talked about electric arc furnace integration into a blast furnace BOF circuit to lower down the CO2 load. So these are the 3 subjects. So see you next time, and thank you. Bye.